Well, I hope you have enjoyed the lectures on anaerobic digestion. Next step is a case study which we would like you to solve. This case study will enable you to dimension an anaerobic digester based on a given waste stream and calculate the amount of biogas that can be produced. So we hope that it gives you a nice view on the contribution that anaerobic digestion can deliver to renewable energy, to waste treatment, or to even chemical production processes. Now, many predict anaerobic digestion a bright future, and indeed it is a still growing sector worldwide. On the other hand, there are old and new issues that challenge anaerobic digestion. It is not all a rosy story. The first aspect to consider is, of course, economics. Anaerobic digestion is not the cheapest way to produce renewable energy. And that's fine because it fulfills other roles such as decreasing the amount of manure, stabilization of waste, and so on. As electricity is relatively cheap, you can wonder whether it makes sense to burn the biogas. It seems better nowadays to make biomethane and recover the carbon besides the energy, and then use that for chemical production, for example. Places like the European Union have a very extensive natural gas grid, which allows coupling small-scale local anaerobic digesters to a centralized gas grid. This means that the green gas can be used anywhere in Europe and generate more value. A second aspect, also derived from economics, is the need for new added value products. Perhaps it should be seen as an opportunity. An example is the production of microbial protein. The world needs more protein to feed a growing world population. And we need more sustainable sources for protein than soy that we derive from the Amazon, or fish grown on other fish that were caught in the Pacific Ocean. We can, as an alternative source, produce compounds like microbial protein, and these are bacteria that can be used as feed or food. And these bacteria can actually be grown on methane, and they need quite some nitrogen. Everything to grow protein is actually present at an anaerobic digester, so we should explore such routes. Alternatively, the biomass entering the digester can first also be fermented, creating products such as carboxylic acids or intermediates of P4, and these carboxylic acids have values as such, or they can be used to further make polymers. Next, let's not forget about the nutrients. Anaerobic digestion liberates nitrogen and phosphorus from waste. We should recover these, as well as the potassium typically present in manure, in a form that can go back to agriculture. Anaerobic digestion needs to also locally close the loop. A major challenge that is outstanding still is the treatment of digestate. This is the effluent, the water coming out of the digester. It's difficult today in many places to get rid of this material in a sustainable and an economic way. So creativity is going to be necessary to deal with this issue. And we hope that by following this section on anaerobic digestion, maybe you can apply your inspiration to this problem. I want to thank you for taking up this course. It was really a pleasure to create it for you. All the best.